Welcome to today's Explainer. We're going to do something really cool today. We're virtually stepping into an advanced R&D lab to tear down and then build the ultimate eco-friendly vehicle of the future. I mean, we're completely rethinking what it even means to drive here. We're moving way past those heavy, battery-loaded electric cars of today and diving into some absolutely incredible, environmentally friendly features that are popping up in the research right now.
Okay, let's just dive right into this blueprint. Today we're going to cover the eco-vehicle blueprint, building with hemp composites, solar skins and cooling paints, lightweighting and EMI shielding, and finally bringing the whole shebang together with a net positive vehicle.
Part 1. The Eco-Vehicle Blueprint, Designing for Zero Emissions. To kick things off, we need to completely rethink vehicle architecture. You see, our current approach to eco-friendly transport has a few massive flaws, namely incredibly heavy batteries that require a ton of energy just to move, and energy-draining systems like traditional air conditioning. We need a totally new blueprint. Our ultimate goal today is a concept called Project Merkaba. It's a conceptual blueprint for a 25-year, zero-tailpipe vehicle. But here's the literally jaw-dropping part, okay? It weighs only 69 kilograms. That is insanely light. And instead of just plugging it into a wall, this car actively harvests ambient energy from the environment around it. It's almost like it's photosynthesizing. It's just a brilliant mashup of high-tech features and hardcore environmental stewardship.
Moving right along to part 2, building with hemp composites, a carbon-negative chassis. To actually get that weight down to 690 kilos, we've got to swap out heavy, carbon-intensive materials for advanced biocomposites. Specifically, we're talking about industrial hemp.
You know, there's this really common misconception that eco-friendly materials have to look, well, kind of rustic or unrefined. But when researchers place a natural hemp fiber door panel right next to a traditional fossil-based one, it proves we can use these incredibly sustainable biocomposites without sacrificing any of that sleek, modern automotive vibe that consumers expect.
And when we actually look at the data comparing these composites, the environmental benefits are just staggering. Traditional plastics take a massive amount of fossil energy to make. Hemp, it needs significantly less primary energy. But here is the real magic trick: biogenic carbon storage. Since hemp is a plant, it literally pulls CO2 out of the atmosphere as it grows, locking that carbon right into the structural fibers of the car. It actively sequesters carbon during its life cycle. It just completely blows non-renewable plastics out of the water. So the big takeaway here is that by using hemp, we're scoring our first major design wins for this future car. We're shaving off a ton of weight by ditching high-density glass fibers, we're drastically slashing greenhouse gas emissions, and we're maximizing land use efficiency. We are basically growing a super sturdy, carbon-storing shell for the passengers. How cool is that?
All right, on to part 3, solar skins and cooling paints for managing exterior energy. So we've got the body built. Now we have to tackle the exterior skin, which honestly has a super tough job. It has to handle blistering solar heat while also somehow harvesting that sunlight for energy.
I want you to picture this. Imagine stepping into a car parked in the blazing summer sun. But instead of burning the back of your legs on the seats, it's already perfectly cool inside. And the AC hasn't even been running. How on earth is that functionally possible without burning through your battery?
Well, the answer lies in this fascinating material science breakthrough called radiative cooling. Now, this isn't just about slapping some white paint on a car to reflect light. No, this is engineered spectral selectivity. The coating actually rejects solar heat and emits thermal energy through a very specific atmospheric transparency window between 8 and 13 micrometers. So it literally beams the car's heat out into the freezing cold of outer space, and it does it completely passively.
And by passively cooling the cabin like this, we're eliminating a huge energy drain. Studies show that a whopping 25 to 33% of the fuel in a standard vehicle can be totally wasted just on heat dissipation and running the air conditioning. Radiative cooling frees up all of that energy.
But hey, we aren't stopping at just cooling. Slapped right on top of this is a seamless perovskite solar skin. Unlike those bulky, heavy silicon solar panels you might be picturing, perovskite is an ultra-thin, highly efficient film. Get this, it is literally 1/100th the thickness of a human hair. And it's flexible, so it conforms to every single crazy curve of the car. With a maximum theoretical efficiency hitting up to 38%, we are turning the car's entire 8.2 square meter surface into a powerhouse, lightweight solar generator.
Okay, moving to part 4, lightweighting and EMI shielding for the internal wiring. We've got our carbon-negative shell, we've got our energy-harvesting skin.
Now let's pop the hood and look at the internal electronics. Modern cars are basically supercomputers on wheels, right? And all those sensitive sensors and cables have to be protected from electromagnetic interference.
But before we shield them, we have to keep the weight down. Recent studies in our source materials reveal that next-generation lightweighting, using those advanced plastics and composites we just talked about, could actually reduce the total vehicle weight by an incredible 35%. And why do we care so much about shaving off weight? Because when you drop 35% of the mass, the resulting fuel and energy consumption plunges by 12 to 20%. This drastically changes our vehicle's overall efficiency equation, which makes our solar panels and ambient energy harvesting way more effective. But here is the catch. Lightweight plastics don't naturally block electromagnetic waves. So, instead of loading up the plastic with heavy carbon fillers, we can use ultra-low-density stainless steel fibers, or SSF. By weaving just a 3.7% volume of these tiny, microscopic metallic fibers into the plastics, we get this massive Faraday cage shielding effect with just a fraction of the weight. And this EMI shielding is absolutely essential in the real world. Just imagine those high-voltage lines pumping massive amounts of energy into the car during a rapid charge, or those hypersensitive self-driving sensors trying to guide you safely down the highway. If electromagnetic noise scrambled those signals, total disaster. SSF technology ensures the car stays safe, smart, and astonishingly light.
All right, the final stretch, Part 5, the net positive vehicle, bringing it all together. Let's see how all these distinct pieces, the hemp chassis, the radiative cooling, the perovskite skin, and the lightweight shielding, combine to build a complete self-sustaining machine.
The completed blueprint showcases a vehicle that doesn't just rely on dragging around a heavy, static battery that you have to plug into a grid, which might still be powered by fossil fuels, by the way. Instead, it uses a multi-source ambient energy flow system.
The whole thing runs on a 13-node energy harvesting matrix. It pulls up to 1,200 watts from the sun using that perovskite film, sure, but it also pulls power from wind friction using triboelectric generators. It pulls from ambient heat using thermoelectric tech, and it captures a massive 70% return from regenerative braking. It's just constantly sipping energy from its surroundings.
And because this car is just so incredibly efficient, remember, it only weighs 690 kilos and cools itself passively, it often generates way more power than it actually needs. That brings us to bidirectional vehicle-to-grid, or V2G tech. With an 11 kilowatt output, your car can literally plug back into your house. It could power your home during a grid outage, or even earn you money by selling clean energy back to the grid during peak hours. A real game changer for sure.
Which perfectly sets up this really powerful quote from the Merkaba concept document. The future of transportation is Measure. Merkaba is a vehicle of light. Over 25 years, it prevents roughly 180 tons of CO2 versus gasoline. By maximizing the energy we take in through advanced harvesting and minimizing the energy we waste through extreme lightweighting and cooling, we end up creating a vehicle that gives back far more to the environment than it ever takes to build.
So it leaves us with a truly fascinating thought to end our explainer today. As these incredible features transition our vehicles from just simple modes of transport into carbon-negative mobile energy hubs, how is that going to entirely reshape the power grids and the cities we live in? Are we just building cars, or are we building millions of decentralized power plants? Definitely something to think about. Thanks for joining me today, and keep exploring.